Okay, today we're going to be talking about a new topic, which is conditional statements. So I'm going to begin by defining the various conditional statements that you can use, and then we'll look at a lot more operators. So right now we know about the arithmetic operators, but today we will talk about the equality operators, the relational operators, and then the logical operators. Once we know about conditional statements, and once we know about these different operators, we can put them together to write code that's more complex. We can write code that is conditional as opposed to the code that we've been writing, which is unconditional. And when I say unconditional, what I mean is up till now, the code we've written is linear. So the computer goes to the main method, it starts at the top, and it linearly executes your code all the way down to the bottom. But sometimes it's nice to have that path of execution or that flow of execution follow different branches depending upon, for example, the value of a variable or the value of an object. So, we might say, okay, if the value of this variable is greater than 10, then execute this code, otherwise execute this code. Okay, at that point, your code, or the execution through your code, is no longer linear, because depending upon the value of a particular variable, we may execute this chunk of code or we may execute this chunk of code. Okay, so it just allows us to write programs that are a little bit more complex, a little bit more sophisticated. Okay, so we're going to begin by looking at the different conditional statements, and all conditional statements are kind of built up on the if statement. And so I'm showing here the if statement. So the if statement starts with the if keyword. Then in parentheses, we have a boolean expression. A boolean expression is an expression that evaluates to either true or false. Okay, and we will look at how do we build these boolean expressions in a bit. So we'll have some sort of expression here that when we evaluate it, it's either true or false. If it's true, then we will enter inside the if statement and we will execute whatever code is contained inside. Then we continue on. If the boolean expression is false, then we will jump over that and continue on. Okay, so this is kind of wrapping a segment of code up in an if statement, and we only execute that code if some condition is true. Okay. Next, we have the if else. So here we have an if statement just like before. If this boolean expression is true, we enter into the if statement and we execute the code there. Else, if that boolean expression was false, we will enter into what's known as the else statement, and we will execute whatever code is found there. So whereas a single if statement by itself, if the boolean expression is true, we do nothing special. We just skip over the if statement and keep going. Here we're actually specifying two different chunks of code that we want to execute depending upon whether the value of the boolean expression is true or false. Okay. One thing to note, the else statement here doesn't have its own boolean expression. Okay, so you can never write else and then have another set of parentheses with another boolean expression. Both the if and the else statements are referencing this top boolean expression. Okay, so if it's true, execute here, else execute here. There's also an else if, so we could say if this boolean expression is true, enter inside the if statement and execute the code that is found there. But if it's false, we're going to do a second check. We're going to evaluate a second boolean expression. Okay, so after the if statement, we have an else if statement. So if the first boolean expression is not true, then we'll come down here. Else if we evaluate the second boolean expression. If that's true, we execute the code inside, else we keep going. So what we basically have here is a series now of checks, right? Is this true? Is this true? Is this true? The very first boolean expression that's true, we will go inside and execute that code. Then we will jump all the way down to the bottom. It's important to know that about else if statements. If you have a sequence of else if, else if, else if, else if, it's possible that many of these boolean expressions could be true. So the computer is going to start at the top, and it's going to find the first boolean expression that evaluates to true. That's the chunk of code it's going to execute. Then it will jump all the way down to the bottom without executing any more boolean expressions, or I'm sorry, without checking any more boolean expressions. Also down here, You can end with an else if you want, that's optional. So we could just say if, else if, else if, else if, and be done. Or we could say if, else if, else if, else if, else. This else here is kind of a catch-all at the end. If nothing was true, the computer checked every single Boolean expression and nothing was ever true, then it will jump down here and execute the code contained in the else statement, okay? So really quickly, just to kind of summarize that, there's kind of two outcomes. A, there is some Boolean expression that's true. Perhaps there's more than one Boolean expression that's true. B, nothing is true. None of the Boolean expressions evaluate to be true. In the former case, if at least one Boolean expression is true, the computer will go through checking Boolean expressions until it finds the one that's true. It will execute the corresponding code, jump to the bottom of everything, and just keep going. In the latter case, where none of the Boolean expressions are true, it'll go through false, 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 false. At the end, it will hit an else statement, and that's what will be executed. Okay, so it's, I think if you stop and think about it, it's actually pretty logical and makes sense. Okay, so for right now, those are the three conditional statements that we're going to be looking at, sorry. So the most basic is just the if statement. If true, do this. Otherwise, nothing. Keep going. Then there's the if else. If true, do this. If it's not true, do that. Last but not least, a series of checks. If, else if, else if, else if, so on and so forth. The else at the end here is optional. Okay, so those are going to be the conditional statements or the conditional structures that we're going to be working with. Now the question becomes, what are these Boolean expressions? What do they look like and how do we write them? So in order to write a Boolean expression, we need to talk about a few more operators. So first, we have the equality and relational operators. So there are two equality operators on your keyboard. If you type equals equals, you are asking if two values are equal to each other. Okay, so A and B are variables, and if I say A equals B, what I'm saying is please check the value inside these variables and see if they're equal to each other. A and B could also be numbers, so you could say 10 equal 5. I'm not sure why you do that, but you could. Okay, so equals equals checks values. Are these two values equal to each other? Similarly, not equals, this is an exclamation mark on your keyboard followed by the equal sign, so not equals, checks if two values are not equal to each other. Okay, so if A and B are not equal to each other, this will evaluate to be true. If A and B are equal to each other, this will evaluate to be false. So let's just sit there for like 2 seconds and think about that. Okay. These four down here then are relational operators because they're asking about the relation between two values. So here we have the less than symbol on your keyboard. So if you said A less than B, you're asking, right, is the value stored in A strictly less than the value stored in B? If that is the case, this operator returns true, otherwise it's false. Here in computer science, in order to get a less than or equal to, you would put them side by side. So you'd type the less than operator and then the equals operator side by side. So A less than or equal to B returns true if A is indeed less than or equal to B, and it returns false otherwise. And then correspondingly, we have the greater than operator. So A greater than B returns true if A is indeed greater than B, and it returns false otherwise. And then A greater than or equal to B. So that operator returns true if the value stored in A is indeed greater than or equal to B, and it will return false otherwise. So these two are the equality operators, and these four are the relational operators. I do want to just quickly highlight, yeah, we'll do red. The equals operator. I'm going to say this, you're still going to make this mistake anyways, but it's good to just get a heads up. At this point, we can have the assignment operator, which is a single equals, or we can have the equality operator, which is two equals. oftentimes students want to check if two values are equal, but you're so used to just hitting a single equals on your keyboard that one of the most common mistakes is for people to just type A equals B. That is not correct. Okay. So if you were to do this, you'll kind of get some wacky behavior. This actually might compile, depending upon the surrounding code, this actually might compile, and you might not realize that it's a problem until you run it and realize I have a logical error somewhere. So I'm going to say it, you're still going to do it, but at least you're forewarned. Okay. Next, we have the logical operators. So the logical operators, there are 3 of them. You have the not operator, which is just an exclamation mark. So it's totally valid to just say exclamation mark variable name, in which case you're saying, please negate this variable. Okay, let me just make a note really quick. Okay, A and B must be boolean variables or boolean expressions. So whereas for the equality and relational operators, the assumption that was that A and B were maybe numeric. So for example, maybe they're ints, and I'm saying, you know, does this integer equal this integer value? Or is this integer less than this integer value? So the assumption here is that the type of these variables is something that it's natural to ask those sorts of questions like ints or doubles. But here for the logical operators, these operators that we're applying are logical in nature. Thus, their operands must be logical as well. So A and B could be 2 Boolean variables, or A and B could be 2 Boolean expressions. You cannot, though, have A and B, for example, be integer types. It doesn't make sense to negate an integer. You may think it makes sense, but it doesn't make sense. So here, A and B, they are Boolean variables or Boolean expressions. Okay, so the not operator here, it is okay to say exclamation mark Boolean variable name. So not game over. That's going to take whatever value is stored in game over, and it's going to return to you the logical negation of that. So if the value is true, it's going to return false. If the value is false, it's going to return true. So it negates it. Similarly here, if A and B are 2 Boolean variables and I say A and B, notice that there's 2 ampersands, and you can find that on your keyboard above the number 7. So if I say A and B, what I'm saying is take the logical values of A and B. They both have to be true for the entire expression A and B to evaluate to true. Okay, and if you even think about the way it sounds in English, A and B, it's basically, you're basically saying A and B have to be true for this whole thing to be true. Contrast that with these 2, this is called the logical OR, and this is on your keyboard, it's like a vertical line, sometimes called a pipe. So you would do 2 of these. So I'd say A, you know, vertical line B. On my keyboard, it's right above the return key. This is the logical OR operator. So here I'm saying A or B. And if you think about that in English, right, if you listen to that A or B, what I'm saying is either A or B has to be true for the whole thing to be true. Okay, so this is logical negation. This is logical and this is logical OR. And the logical and is a much stricter operator. They both have to be true, A and B. The logical OR is a much more permissive logical operator. Either A or B can be true. Okay, what I'm showing here is the truth table. Okay, so we're going to go through and we're going to fill in this table with trues and falses. So assuming that A is true and B is true. So we have two Boolean variables that are both storing the value of true. If you were to type not A, what that would evaluate to is false. Okay, so it's saying take the value stored in A, which is true, and negate it. If you were to say A and B, right, true and true is true. Okay, that's that special case where they both happen to be true, thus the entire expression evaluates to true. Lastly, A or B, this is also true. Okay. In this case, they're both true. It's kind of, I don't know, fill in some sort of expression. But basically, we only need one of them to be true. We got lucky, they were both true. Thus, the entire thing, the entire expression evaluates to true. Okay, next line. So now let's assume that A is true and B is false, right? So how does that change the outcome of these operators? So here, not A, right? If A is true, this would return false. A and B, this is going to be false. So they are not both true. And again, the and operator is a very strict operator. They both have to be true. But A or B is still true, right? Because A is true, the whole expression will evaluate to be true. Again, the logical or is a much more permissive operator. Okay, next, if A is false and B is true, okay, if we said not A, that would return true. Again, it's saying take the logical value stored in A, which is false, and negate it. And then the negation of false is true. Here, if we said A and B, again, this is false. For the same reason as above, they both have to be true. And in this case, they're not both true, right? A is false. Similarly, A or B is still true for the same reason as above, right? Only one of them has to be true, and thankfully B satisfies that. Okay, last but not least, if A is false and B is false, not A evaluates to true. A and B most certainly evaluates to false. We need both of them to be true, and in fact, neither are true. They are both false. So overall, that expression will evaluate to false. Similarly, A or B is also going to be false. Okay. One of them needed to be true. Neither of them were true. Overall, it evaluates to false. So here, if we look at A and B, it's a very strict operator. It only returns true in that special case where both of them are true. Any other time, it's going to return false. The logical or is kind of the inverse of that. It's a much more permissive operator. It's almost always going to return true. It only returns false in that very special case where they both happen to be false. Okay. So these are the equality and relational operators, and these are the logical operators. We can put these together then to build Boolean expressions that we want to test in our code. So, okay, we're going to do some practice now. So what I have here is just some code floating, maybe the main method, I don't know. Okay, I have two integer variables. Notice I'm declaring them in the same line, and that's okay. So we have value 1, and I'm setting that to initial value of 5, and value 2, and I'm setting that to initial value of 10. And then we have a single Boolean variable that I called done, and it equals true. Given the value of these three variables, I want you to go through then, evaluate each of these Boolean expressions, and write down whether you think they're true or false. Okay, so for example, value 1 greater than or equal to value 2. Okay, is it true that value 1 is greater than or equal to value 2? So you need to look at the values stored in those variables and see, is it true that value 1 is greater than or equal to value 2? You'll see that these expressions get more complicated as we go on. For example, down here, write -5 less than or equal to value 1 and value 1 less than or equal to 5. Okay, so here I'm actually combining logical and relational operators into the same expression. So the way that the computer is going to tackle that is for the logical and the logical operator, we first need to evaluate the left-hand side and we need to evaluate the right-hand side once we've evaluated them. So once I know, is this true? Is this true? Then we can apply the logical operators. Okay, so said another way, the relational operators have higher precedence. We're going to evaluate those first, then we'll apply the logical operator. Okay, we can always use parentheses just like usual in order to enforce some sort of precedence. So here I'm putting value 1 less than value 2 in parentheses, then I'm negating that whole thing. If I didn't have parentheses here, this negation operator would just apply to value 1. Okay, so with the parentheses, I'm saying no. First evaluate this relational operator, then negate whatever value you get and OR that with whatever is stored in done. Okay. Okay, so pause the video, take however long you need, go through and make predictions on each of these, and then we'll see what the answers are. Okay. Okay, so here we go. All right, so I'm showing in red here the answers. I think most of these are straightforward. No, 5 is not greater than or equal to 10. Not much to say about that. Okay. Is 5 plus 5 greater than or equal to 10? Yes, it is. 10 is equal to 10. We were saved because we had that equal sign, greater than or equal to. If we had just had, right, if that was not there, and we had said, is 10 strictly greater than 10, that answer would have been false. 10 is not strictly greater than 10, but it is greater than or equal to 10. So you kind of left out there. Here is 5 strictly less than 5. No, it's not, for the same reason that I just talked about. Is 5 equal to 10? No, it's not. Okay, here I'm saying is 5 equal to 10, which is false. Then I'm negating that. So the result of that expression is true. Here on the left-hand side is -5 less than or equal to 5. Yes, it is. Is 5 less than or equal to 5? Yes, it is. Again, right, thankfully we have that equality operator. So the left-hand side is true, the right-hand side is true. We're anding it together, thus the whole thing is true. Up here, interestingly enough, it really doesn't matter what this left-hand side evaluates to, because we're ORing it with done, and done stores the value true. So regardless of what happens on the left-hand side, this whole expression is going to be true. Now, if we did want to evaluate the left-hand side, value 1 is less than value 2, so that's true, but then we're negating it, so that's false. Okay, so we have false or true, which is true. Okay, here we're negating done, so we know that this side is false, so that's not going to help us. Looking at this first side though, value 1 greater than value 2, that's also false, right? 5 is not greater than 10. So both sides are false, thus the overall expression evaluates to false. For I, we already know the left-hand side is false, thus it really doesn't matter what comes here. It doesn't matter, the whole thing's false. This I here is kind of a good example of the way that Java is going to evaluate Boolean expressions. If you have a Boolean expression that, and you're anding, so you're saying this and this and this and this, just like we have here, right? We have one expression and another expression. Java will begin at the beginning, so it'll evaluate that first expression, and it will only keep evaluating expressions if everything's true. But as soon as it finds a false, we know the whole thing has to be false, and we can just stop evaluating. So I can't remember what this is called. It's either called short-circuiting or like lazy evaluation. I think short-circuiting, whatever. This is going to come into play later when we look at objects and arrays and stuff like that. Okay. All of that to say, this whole thing is false, and we know that just by this first expression here. We don't even need to go on. Here, done or not done, no matter what the value of done is, this will always be true, because basically you're saying done or its negation. One of those has to be true. Last but not least, we have value 1 greater than value 2. That's false, but done is true. So if we OR that together, this whole thing is true. This second expression here, we have not done, that's false, but then we have value 2 greater than value 1. So thankfully, that's true. Okay, ORing them together, again, the whole thing is true. True and true evaluates overall to true. Okay, so if you are surprised by anything, you can kind of stop the video, go back to my explanation, think about it a little bit more. If you're still surprised, then you can make that one of your questions for the week. Okay. Last but not least, I want to look at some actual examples of taking these if statements, these conditional statements, and these new operators and putting them together to write actual code. And one of the things I want to emphasize, and that I'm going to be emphasizing as we talk about conditionals, is once you introduce conditionals, there's a lot of ways to write the same piece of code. In other words, there's a lot of logical ways to structure whatever it is you want to structure. So we're going to see an example of that here. Okay, so here's an example of a withdrawal method. This method is a little bit different than something we've seen before, and we'll get to that in a second. But we have public static void withdraw, and then the input is the amount that you want to withdraw, which is probably a double, it's some monetary amount. And the first question we're saying is if the balance in your account is less than the amount you want to withdraw, then I'm going to print out error, not enough funds, or insufficient funds, right? If you've got $100 in your bank account and you want to withdraw 500, although it would be nice if the world works that way, it does not work that way. Okay, so we're going to do a system.out.print, error, insufficient funds. Else, if balance is greater than or equal to amount, then we'll enter the else statement and we will actually do the withdrawal. So balance equals balance minus amount. Okay, so one of these two pieces of code will be executed. Now, as I said, this is actually a good question, and you should pause the video. Why? Why is this method a little bit different from any method we've seen before? I mean, other than the fact that it has a conditional and we've never seen that. But I claim beyond the conditional, there's something odd about this method or something maybe interesting about this method. So you should pause the video for however long, come up with a guess. Why is this method different from what we've seen before? Why is it a little bit interesting? And then we'll pick up. Okay, hopefully you actually did that. Here's why. Balance. Balance is a variable that was not declared in the method. It also was not passed as an input. So it should make you a little suspicious. Where is balance coming from? Where was balance declared? What is the scope of balance? So this is the first time we've seen a variable that is not declared in a method, so it's not local to the method, but it also wasn't passed into us, but we can still use it and we can still refer to it. And so this is a little bit of a preview for the next topic we're going to be talking about, which are classes. But in this example, I kind of just threw that in a little bit. It doesn't really matter as long as you understand kind of the logic of you have some balance in your checking account and you want to withdraw. That's basically all you need. But I thought I would, in case that was kind of intriguing to you, talk about that a little bit. Okay, that's a little bit of a preview for what's coming up. Okay, here you go. This is a method. It's a withdraw method. Perfectly good method. It uses an if-else statement, and there's nothing wrong with it. Great method. Okay, you could write this method differently. So here's a different way that we could write this method. All right, public static void withdraw takes in the same input double amount. If balance is less than amount, system.out.println, error, not enough funds, return. Okay, I'm using this return keyword to force an exit from the method so that if we ever reach this line of code here, okay, so I'll do that in a darker color. So if we reach this line of code, we know there must be sufficient funds. So we can kind of leverage, or we can use the return keyword to control the flow of execution here. If we hit this return keyword, it must mean there wasn't enough funds. We've printed, we will then exit the method, and we will never reach this line of code here. In fact, we will only ever reach this line of code if the if statement is false. Okay, so if it's false, we'll jump down here, execute that, and we're done. Okay, this is a little bit of a tighter or a little bit of a more concise piece of code that accomplishes the same objective, right? And we're using the return keyword to our advantage here. Here's a third way we could write this method. This is slightly different. So one thing we could do is, again, public static void withdraw. We take in the same input double amount. Here I'm saying if balance is greater than or equal to amount. So I'm asking a positive question. Do they have enough funds? Is balance greater than or equal to amount? If they do have enough funds, we'll go ahead and do the transaction. So we'll do the withdrawal. If they do not have enough funds, we would immediately skip over that and exit the method. This here is a method that's silently handling the errors. And sometimes you'll hear people talk about that, like it silently handles the errors, meaning sometimes, oftentimes, we may not want to print an error message because our code is just one tiny piece of code in a larger system of code. And if everyone decided to print out every single error message, then the user who is only wanting to withdraw money is going to see all of these ridiculous print statements. This variable is negative, this with it gets overwhelming. I forget which homework. There's a homework assignment though. I think I explicitly say in the homework assignment, please do not put in print statements. It really gets overwhelming. So here, if an error happens, meaning not a code error, but if the user tries to withdraw more money than is in their account, we are not telling them. We are simply silently handling that by skipping the if statement and exiting, and we don't do anything and we don't say anything. If there are sufficient funds, then and only then do we enter the if statement and we execute that. Okay, so just showing you some actual examples of how if statements are used in conjunction with relational and logical operators, and also kind of getting you started on this notion of as soon as you introduce conditionals, there's no one way to write your code. There's going to be lots of different ways. And part of using conditionals is kind of thinking about what's the tightest, most concise way that I can use these conditionals. And you'll get lots of practice with that. Okay, that is it. Let's go back to the beginning and do a quick recap. So the three conditional statements that we looked at were the if statement. It's kind of your bread and butter. Then there's the if-else statement. Note the else does not have its own Boolean expression. That's a really common error. It doesn't have it. Then there's the if, else if, so on and so forth. This one you kind of need to, you need to understand what happens if one or more of the Boolean expressions is true or if none of the Boolean expressions is true. And one of the most important things to remember is as soon as one of the Boolean expressions is true, we execute that chunk of code, and then we do not continue evaluating Boolean expressions. Do not pass go, do not collect $200. We jump past the entire set of statements and just keep going. That's really important to know. Next, we talked about equality and relational operators, so you should know what each of these means. The logical operators, these are assuming A and B are logical or Boolean variables or expressions. You should understand, given two Boolean variables, what the outcome would be of applying any of these operators. Last but not least, this is practice. You're going to get lots more practice. And actually, I find that for most students, conditionals are kind of the one topic that most people seem to click with. So you'll get lots of practice, and I think the practice ends up being more fun than anything. And then last but not least, just showing you, here's how you would actually put these two things together. And there's so many different ways you can write your code. And you really are just trying to think about, like, what do I really want to accomplish and what's kind of the tightest way to accomplish that. Okay, so we could use an if else. We could be a little bit slick and use just an if by exploiting the return keyword, right? Or we could test for the positive. So here I tested if balance is less than amount. We also could be testing if balance is greater than or equal to amount. And those all accomplish the same goal. Okay, that's that, and we're done.